Welcome back, everybody. This talk is rapid function development. I'm Frank Lesniak. I'm a senior architect at West Monroe. Thanks, Bonnie, for the intro. I've got my contact information on the bottom of this slide. My role with PowerShell is really specializing in backward compatibility. So I kind of joke that I'm not that good at PowerShell as a result. I don't use a lot of the newer features, et cetera. And sometimes people point that out, but it's fairly intentional. And just one shout out, just being here in the Chicago area, I'm a board member with DuPage Animal Friends, which is a foundation that supports DuPage County Animal Services, which is an open admission animal shelter. And for those that know what open admission means, it's a very important part of the community, and I'm glad to be part of this organization. And I will let my colleague David introduce himself.
Yeah, thanks, Frank. My name is David Wiggs. Happy to be here. I work in security architecture and engineering at Bain & Company. My favorite PowerShell modules are Azure AZ module, Import Excel, Azure AD, and recently I've been back in PowerSploit. I've spent a little bit of time in Azure. That's probably where my career has been situated so far, and recently I've got some certifications to try and put some feathers in my cap. But what I usually tell people is I used GitHub and Git command today, and hopefully that means that you think I'm not a complete idiot, but know what I'm doing. In any case, I'm an all-around foodie. I love pizza. I'm not going to say what's best in Chicago. No slice is the wrong slice. But if you want to follow along with my thoughts, feel free to follow my blog at awshole.com. But with that, we're going to go ahead and get into the agenda and the learning objectives of this talk. So we plan to go over basically a little bit of brief background on some function basics. After that, we're going to talk about maybe doing some gut checks on when you should be migrating from a scripting point of view to doing functional programming. And then we're going to give some examples of how you can use functions to build scalable and maintainable code. And through those topics, basically, we're going to hopefully provide some scaffolding or templates on ways that you can accelerate your function development. And also, we're going to include some thoughts on how you can wrap all of your nice, good, shiny functions into a library that's sustainable. And we'll go over the concept of dot sourcing. And so with that, I'm going to go ahead and let Frank take us through what an actual function is, and we'll go from there.
Thanks, David. People love your blog, by the way. Just keeping an eye on the chat here. All right, so a function, right? So this is really for people that are brand new, right? A function is a way to really wrap your code up. It's a way to make it ready for reuse if you think you're going to use it again in the future, or if you need to give it to somebody else. And that's kind of what I mean by portability, right? One important concept with functions is they have a single output, and that's really important. We're going to come back to that throughout this talk, and you'll see why. And of course, they should have standardized input or no input. It's perfectly acceptable to have a function that does something, and maybe the thing it's doing, the data it's gathering, et cetera, is just part of the system natively, and so you don't need to provide it with any input. Functions are commands in PowerShell ultimately, and they're kind of like a commandlet. They often look very similar, and to the user, they may not even know the difference. And then one more important point to know is that when you create a function, you're defining it. And it sits there in memory, but it doesn't do anything until you actually invoke it. So you as the operator at the PowerShell prompt or the script writer that's using the function, you need to take action to invoke that function. And just a real simple example for people that are newer and haven't seen these before, this is just a couple screenshots showing the same function. And this is a real simple one that just tests to see if the current operating system is Windows. And you can see the upper left is a Windows system, and it's returning true. Of course, it's Windows, and the lower right, I'm sorry, sorry for the bad colors here. Mac OS likes to use yellow on white background by default. And so anyway, Mac OS returns false. Of course, it's not Windows. So again, one of the key things we want you to know here is that a function is defined and it's there for use until PowerShell script or scope ends. And it's your job to then call that script. Sorry, call the function. Apologies. Go ahead, David.
Yeah, exactly. And so now that we kind of know, at least have our bearings on what a function is, and when we can use it and how we have to invoke it, let's talk about when some, kind of foundational elements will be when you start to use functions. And some of these might be very intuitive, or some people might already be realizing this, but if you're doing something over and over again, that's something like recursion or some sort of algorithm. That's a very good use case for a function. Instead of having to type that code over and over and over again, you can repeatedly call a much shorter line. it's along the same lines, anticipated future reuse. Maybe it's not within the same script, but maybe you have several scripts that leverage some sort of authentication mechanism that you're continuing to find yourself typing out all over again. And so functionalizing that and compartmentalizing it is very straightforward. But I think that a little bit more, you know, elegantly put is the tipping point of maintainability. Everyone's probably got their own comfortable place that maybe it's 20 lines, 100 lines, 500 lines, for 1,000 lines that you think that, hey, maybe this is just too big of a pizza. We need to break it down into smaller bites. That's very much the approach to keeping things simple, keeping things self-documenting as much as possible rather than having lots of lines to parse logic on, but very small functions that are hopefully appropriately named, so that we can hide some of that complexity that's going on in the background, and so that anyone that's actually reviewing a script that's calling functions can really kind of logically read through it in the English language rather than having to, you know, decipher logic. And so when we know about this way that we're going to be going through, you know, our gut checks, I'm going to let Frank actually walk through the process of getting a script into a functional state.
Yeah, thanks, David. So, you know, when you think about writing functions, a lot of people will tell you, hey, it's really best to set out from the beginning and think about, you know, all the things that your function will do, and know how everyone's going to use your function, know what types of errors and exceptions you might face, know all the valid input variations and object types, so like what kind of input is allowed and expected. Know the exact type of output, right? Including when something goes wrong, what kind of output should come out. And you know, you might also expect to win the lottery, or if you're like Marty McFly here, you might, you know, go back to the future and be disappointed at seeing Star Wars Episode 7. So in reality, you know, it goes a little bit differently, I feel, a lot of the time. This is an example. Wow, I just wrote 20 lines. I better wrap these in a function so that people know what I'm doing here. And so just to kind of show that this isn't 20 lines, this is kind of a simple set of PowerShell, right? It's 3 lines. It's pretty readable, but you know, for those that don't know, this is doing something in Exchange Online or Exchange on premises. And if you're not an Exchange person, you may not really know what this is doing, even if you're good at PowerShell. So, boy, it'd be helpful to kind of wrap this in a function, right? So I've done that here, and it's called get Exchange mailbox last login information. And now if you look at line 8, it's very clear what I'm doing, right? I'm going and getting all the last login timestamps and associated metadata for each mailbox in Exchange. So that helps. Another example is, wow, I just did the same operation 3 times. I should probably wrap this into a function to cut down on lines, right? So here's an example of that. This is calculating the volume of a sphere 3 different times, different spheres, of course. So the spheres are numbered, and they have different radii. And we can throw this in a function pretty easily. We're going to come back to this a little bit later, so we'll dig into this a little bit more. But you could just see from the line count perspective, this has gone down from 20 lines to 12, and it's a lot cleaner. Some of you might be seeing this and saying, args, worst presentation ever. Yeah, I know, I'm sorry. We'll come back to that and explain why args is used here later, so just bear with us. And the last kind of real world example is, you know, you might be writing an algorithm. Oh, sorry, David, I'll let you kind of explain this. This is your slide.
No, it's okay. It goes along with these real world examples of where when you're filling out an algorithm, you never really know what it's going to look like in the end, or it's very unlikely that you do. You probably have this state of chaos that's going in your mind of trying to sound something out. And then typically you'll hit that moment of clarity. Well, things will just, you know, start to line up in your mind, and you'll see exactly what you need to be doing. And then finally after that, you'll actually get down to writing something down in nice syntax, making it look pretty. And so it's really difficult to follow that theoretical path of developing functions. It's really much more organic, saying that there's not a wrong way to do it. And if you are progressive enough to try and functional program ahead of time, more power to you. It's just, don't think that you're doing it wrong if you're doing exactly what Frank and I are demonstrating here. And so now that we've kind of gone through what exactly, you know, kind of our gut checks, what a function is, how we can approach developing functions. Now we're going to get into actually building scalable and maintainable code. Frank and I are going to share some nuggets that we've got, you know, gathered throughout the years about scaffolding, what it really means, standardizing inputs and error handling, doing progress bars and contextual awareness, all to culminate in building a functional library and dot sourcing. And so with that, I'm going to go ahead and let Frank start explaining what we really mean by scaffolding.
Thanks, David. Yeah, so scaffolding. Yeah, when you hear that term, you might think of something like this, right? A construction site, maybe repair on a submarine, as you're seeing in this photo. But really, what we mean by that is we mean templates or maybe accelerators, or to be honest, both. The idea is that these are scaffolds are things that make your scripting easier. They're there to help you. They're there to speed you up. And so we like them. And by the way, I think that's a Frank and David term. I'm not sure I've heard that in the PowerShell community, so maybe that's something new for everybody. And there's kind of two different types of scaffolds, if you will, or at least template files. And so one of them is, of course, having a dedicated file that you can basically duplicate the code, right? So you can open the file, copy the code in it, paste it into your script, rename your function, and then, of course, complete the body of the script and be on your way. That's one way to do things. Perhaps if you're writing a really long script, you might also put some commented out function code at the top of your script. And because maybe you need to write 20 functions in the same script, as an example. In this case, you could copy that code, paste it where you need it, and then if you're using VS Code, you can toggle line comment to uncomment that code, rename the function, and then be on your way to complete the code.
Yeah. And while having a starting point is always good, the reference file or maybe a snippet at the top of a file, there are additional ways that smarter people than myself have implemented for us to go even faster than this and implement good practices while not taking a lot of time to do it. Specifically in VS Code, to Mr. Snover's hat tip, you can create snippets in JSON, and so you can write your own tab completes essentially. And in this case, if I wanted to do a for each with a try catch inside, but I'm too lazy and I don't want to input a progress bar every single time, and I don't want to do a error output to the stream, that's lazy. But if I include it in a tab complete, it really enables us to do the right thing while not spending a lot of time. So it makes it okay to be lazy in that case. So using scaffolding like this will allow us to accelerate functional development, which is probably that mentality of taking smaller bites, and then also allows it to do it quickly and with a standard approach. And so moving on, outside of scaffolding, another element of, again, doing rapid function development is always standardizing inputs and outputs. And again, why standardize? Well, beyond, the self-evident, idea that, everything that's probably standardized is a little bit more easy to consume, there's the idea that there's an infinite level of possibilities in the PowerShell world. PowerShell is not strongly typed, meaning that you have lots of different object types that you can work with by nature, and of course that can lead to upstream errors causing unknown impacts down in the code later. And you can write your functions in a way that, if an error is thrown, you can handle them. You can have input validation to where you're accepting certain levels of, object types, whether it's a string or an integer. Maybe you need to accept both. But at the very least, if you're going to be approaching functional development, you want to be able to standardize things at the comment, at the very top. Hey, this is what this function is doing. Please pass it this set of inputs. This is what it's expecting. Otherwise your function really just kind of feels like it's down in the trenches, and what else can it do except spit a lot of red garbly-gook to the screen. So please start standardizing inputs. Beyond that, it's also a good thing because of usability. Too many, if you're gonna try and make your function do too many things to account for too many permutations in your code, it's gonna make it a lot more difficult to follow. It's gonna make it a lot more complex to review. So have the mentality of trying to make your code perform a single task. Do one thing well rather than trying to do everything. That will also make it more self-documenting, right? You read the name of the function, it does one thing. You have a very intuitive nature of how to use the function. That reinforces, again, functions should have standardized inputs, but a single output. And tying that simplicity together will also enable us to go quickly. You even have to consider the case when your function doesn't necessarily run correctly, but what if it has an error? If there's only one expected output, that error might be a little bit more easy to debug in that case. We'll get back to that in a little bit.
And this is a good time for me to jump in and just kind of give this quick aside on passing by reference. So for those that have worked with PowerShell functions, when you pass input to a function normally, you're basically providing kind of like a copy of that data or that object to the function. And this is just a quick code snippet on the screen here that kind of shows this, right? So if you look at what this function is doing, it's really concatenating two strings, right? Prefix and a suffix. But interestingly, it's storing that result back in the arguments. Like, so this is the function input. It's storing it back there. And if you then look at what I'm passing, you can see I'm passing I love as the prefix and lamp as the suffix. So we would expect that when these get concatenated, it should say I love lamp. And sure enough, in the function, it does say I love lamp. So in the function, I've stored my result and overwritten an input. That's kind of interesting. But notice it doesn't live on as the function terminates. So outside of the function, when the function completes, it's still just I love at the bottom, right? So how can we do this differently? Well, we can think about passing by reference, perhaps. And if we do this, then our output can kind of live on outside of the function. So just in terms of syntax, here's a couple red boxes that show you what this looks like. So when I pass the data to the function, I'm casting it to a reference variable type. You can see that on the bottom red box there. And then inside the function, I'm using a different variable name that tells me, that it's a reference type. And inside the function, when I actually go to do the concatenation, of course, that looks a little bit different. I have to, go and access the value of the reference, and then I can concatenate those two things. And notice I write it back to the reference value. And so when I do that, now my data lives on outside of the actual function itself. And so some of you might be looking at this and saying, yeah, that's great, Frank. But trust me, we're going to come back to this. It's a pretty important concept. All right, and I'm seeing people trolling about right host. Yeah, I know. It's okay. We're going to continue with the trolling here. So let's bring it on.
Just
Let's go.
brace yourselves.
Yeah,
Yes.
brace yourself. All right, we're going to talk about args here, all right? And again, some of you are probably saying args, worst presentation ever. Yeah, I know. This is not favored by the community. Okay, it's not very PowerShell-like. Doesn't look like a commandlet, right? You saw when I called that function, it was, I'm spacing between the arguments. That does not look like a normal commandlet. Using args is also rigidly structured, although I would say that is not always a bad thing. Back to one of David's points earlier, he mentioned that you want to really focus on doing one thing and doing it really well. And I would say that this is actually a way to kind of force that issue a little bit. But again, optional parameters get a bit messy. So if you think about two different use cases for a particular function, where perhaps you need to accept 5 parameters or 5 arguments under normal circumstances, but then you have an alternate use case where you only have 3. That gets a little bit weird with arguments. You can do it, but it's not very clean. And some of you might be saying, well, how do I splat using args? And yeah, good point. You can't use splat. At least I'm not aware of a way to do it. So yeah, args is not great, not favored by the community. And just to be clear, this is a set of positional arguments. I've already kind of shown this, but I didn't really focus on it. So just to kind of bring this front and center, this is an example here. And yes, I'm using right host. I'm sorry. Don't do that in reality. Just quickly demonstrating that. So you can see in the function call, right, I'm providing 3 arguments, 42, the value for pi, and then the word third in a string. And of course, those get written out just as you would expect. And notice I'm accessing them like args index 0, args index 1, args index 2. So they're positional, right? Hopefully that makes sense. The one thing about args I would argue is that it's a faster way to convert your existing non-functionalized code. And I'm just going to show an example of this. By no means am I fully endorsing this approach, but it's a good stepping stone for a lot of folks, I think. And so if you have a code like this, remember I showed this earlier, this is the code for determining the volume of a sphere. And if I look at the first example here and really look at what it differs in this code between the 3 different iterations of the same set of code, it's really the sphere number and the radius of the sphere, right? Those are the 3 things that are different across these 3 examples. So if I really zero in on that and I think about those are probably my inputs, I can restructure my code before I put it into a function. I can make it look like this, right? And so if you look at this section is identical now between the 2 examples, right? So this is very likely going to become my function, or at least the main body of my function. And if you look at my inputs, I'm clearly referencing those, in the body of the function. So that's good, right? But I need to check all the variables in my do work section to make sure that they're all that I'm not referencing any variables that exist outside of this block of code. So I'm gonna, like an insane person, draw a bunch of arrows. And what I'm looking for here is that, all the arrows are contained within this section of code. I don't have any arrows coming from like way above, for example. And also all the arrows are pointing to the bottom right. And I know it's kind of silly, but like it's just a quick visual way to determine, is my code executing in a linear way, and am I referencing things that were defined above? So everything's pointing to the bottom right. So that tells me I've pretty well encapsulated the code. And honestly, what I would do at this point is I would rerun my script and make sure that the output looks the same as it did before I modified it in this way. So I'm kind of getting it ready to become a function, right? And next, I can actually make it a function, right? So here's my body of code that is the same, right? It's here. And notice what I've done with the variables that are inputs, right? I've just simply changed them from the values themselves over to using args, right? Now, again, I know args isn't great. There's issues with that. But this is a really simple way to transition existing code to a function. Then if you look at the bottom, I mean, it's a real simple call to the function. So that's what that looks like with args. So again, perhaps the faster way to convert existing non-functionalized code. One big negative, other than what we've already shared, is it's really a lot more effort to enforce input validation. So I'm going to show that here. Let's say in that same volume of sphere function, I wanted to do some input validation, right? So the first thing I might need to do is check to see if I've got enough inputs, right? And so I'm having to write code to check the count of arguments that I've received. And if you then look beyond that initial count, all right, I need to basically check each argument individually. And I've collapsed the second argument in lines 21 to 25. Oops, sorry. But you can see kind of expanded here on line 13. I'm looking at the first argument, right? I'm making sure it's not null, first of all. And then second, I'm checking to make sure that I'm receiving a number, right? Or that it's at least a numeric format. It could be a string with this kind of visual basic information object approach. I can put the number 1 in quotes and pass that, and it would be acceptable. But I can't pass like a word like Frank to the function. And so to show what that looks like, here's just a quick example, right? Of course, if I pass A and 20, it's going to throw an error. If I pass 2 and 7.5 in quotes as a string, that's acceptable and it will calculate. So, you have to write your own code to handle errors if you use args. That's kind of a pain in the butt, especially if you have a lot of inputs. But on the flip side, you can really control at a more granular level what the user sees when an error occurs. So we got there. It was just more work.
Yeah, that's probably a good way to say we got there, right? So although arguments is probably a really good approach to start functionalizing things, it might not be the most, community preferred way to do things of standardizing inputs. Params is our tool here in PowerShell. It quickly allows typecasting, methods for optional parameters, right? You guys are highly aware of splatting, as I've seen by the chat. Order doesn't matter like they do in arguments. We can assign default values, like the list goes on. We can use commandlet binding to write to our streams. We don't have to do flags anymore. I think that parameters are probably one of the single coolest things about PowerShell. It makes it very straightforward, self-documenting. Those are all principles I strive for. Yes, parameter sets too, right? The list of complexities goes on. I think that once you start getting your feet wet in functional programming and using parameters and standardizing inputs, you realize that, a lot of the elegant programming can be done with handling inputs and parameters and defining sets there. But just to get started, I'm definitely an advocate of the way that Frank approaches things as well. But moving into an example of how we can cut down on all of that logic that Frank did in about 24 lines, we can define several parameters here in just about a dozen. I'm a big fan of almond style. I'll die on a hill. And so I like lots of line count, as long as it's a purposeful line. But in this case, we can enforce the type of variable, whether it's required or not, the name of it, and also include things that'll help us handle errors later, like writing to verbose with commandlet binding. Essentially, it's just a different syntax than defining arguments, but it does avoid the need to kind of doing that input sanitization or validation at the beginning of all your scripts. If you use parameters when you're doing functional development, PowerShell will be that gate for you to do that sanitization before your code out even has to look at it. So, as I mentioned, parameters and commandlet binding kind of naturally remove some of the error handling that you have to do when we talk about standardizing inputs, but it doesn't remove all of it. And so I'm gonna let Frank continue on and talk about, error handling in this case and why we need to think about it even beyond just input validation.
Thanks, David. Yeah, so error handling, it's really important, right? You need to be able to inform that person at the keyboard who's running your script that something went wrong, right? That person may need to halt the script, or maybe their internet connection blipped and they're working against Azure or Office 365, sorry, Microsoft 365, and maybe they need to retry whatever it was they were doing. Or maybe they need to debug the script and fix some code, right? So it's important to tell the operator what happened. But it's also, I would argue, more important to inform any kind of downstream processes that something went wrong. So if you think about a script that performs multiple actions in sequence, like maybe I'm doing something with a storage account in Azure and then I'm creating a virtual machine in that storage account, I need to, like if the storage account fails to create, I need to probably inform that downstream step that, hey, my prerequisite isn't there, so don't continue, or maybe do something differently. So, again, I mentioned this already, but in some cases, the script might want to automatically retry its operation if there's a failure. Like perhaps, again, maybe you're getting throttled by Microsoft 365 or there's a connection blip or something like that. So a lot of reasons to need to potentially retry the operation. I've talked about downstream processes, and then, you can always record the error using logging or telemetry if you want to get really fancy. So just going back up to the first example of kind of informing the operator at the keyboard, I've got a simple code snippet here showing just that. This is, again, really basic, but there's different streams out there, right? Error, warning, verbose, debug, and there's others as well. We don't have them all on the screen here. Writing to these is a good way to tell somebody who's at that keyboard that something went wrong. And it's good if you also give them enough information to really know what happened, what went wrong, and how to take action on it. And that operator is knowledgeable enough to then take action on it, right? I'm being really clear there with those ands, because I think if you kind of throw bad errors or throw a lot of noise at the operator, it can actually cause confusion, maybe even panic, or in the actual worst case, if you're doing something really critical, it might cause them to take the wrong action and potentially take something offline or who knows what, right? It depends on what the script is doing, of course. And I really do feel like if all you're doing is, if all you're doing to handle errors is writing them to the stream, then it's definitely more difficult for your downstream processes to ingest those errors and understand that an error occurred. Trust me, it's just more difficult to do this programmatically than some of the other techniques we're going to share. So how do you do this programmatically? Well, we mentioned writing to a stream. You can write to a stream and then interpret that information programmatically, but it's a little bit more difficult to do that. You're comparing the error stream, for example, before you ran your function and the error stream after you ran your function, and it's just a bit clunky, but you could do it. I think it's better to return either a known output, so maybe you return null when an error occurs, as opposed to whatever it was you were trying to return in the first place. Or you can return a success failure code, like an integer, for example, that is perhaps separate from the output of the function. And one thing to note is that these options are not mutually exclusive. You can do all these things or some of them. It's sort of up to you, and it depends on how you're trying to author your code. But I would encourage you to at least think about that, the latter two bullets, in terms of how you might convey errors to the caller. And you might be thinking, you might be looking at the third bullet and saying, but Frank, wait a minute, return a success failure code separately from the output. What? You said there's only one output on a function. And that's correct. We're going to come back to that. So just hold that thought for a moment. So let's look at a function from a block diagram level, right? At its very basic level, this is what it looks like, right? It's this big blue box and it's got a gear in the middle. It's doing something, right? And again, functions can only have one output, right? But wouldn't it be nice if we can have two? I think it would be. So remember earlier, we talked about passing by reference, right? With my I love lamp example, that was pretty cool. What if we use that same technique to modify objects that were passed as input, right? Doesn't that mean we can get two or more objects coming out of our function? So like, for example, a success failure code and the return object itself, that would be nice. So if we did that, we can go back and update our block diagram. It would look more like this, right? We have our output, of course, yes, and there is one output on the right side. But now we've got this ability to pass by reference and have more objects modified. So that's kind of cool. And this might look like the following on your, in your function header as you're, um, kind of defining that that function information in comments. And by the way, this is a screenshot of one of our function scaffolds that we're going to provide on my GitHub here this afternoon. So check my GitHub link. I'll bring it up at the end of this talk, and these files will be posted. But yeah, anyway, notice I call out that the first argument is a reference to an object that will be used to store output. So I'm expecting the person who's calling my function to define a new object and pass it by reference to this function. And then notice at the bottom, I'm going to return 0 if the function is successful. If the operation occurred and did what I wanted it to do, I'm going to send a 0 code back as the true function output, right? So if you think about the right-hand side of that diagram I showed earlier, it's going to get a 0 when things work well. And the actual output itself, the thing I'm generating, will get stored in this first argument. So the happy path looks like this, if you look later down in the function. When no error occurs, I then take my output and I store it in the referenced variable's value, and I'm returning that 0 at the very bottom. See that? So that's the happy path. On the other hand, when something bad happens and an error occurs, well, in that case, I might write to a stream, as you're kind of seeing in the code up top, right? But I'm not touching the output. Notice I'm not doing anything with that reference variable when an error occurs in this example. And I'm sending that -1 back on the pipeline. So that's how I'm signaling that an error occurred in this example. So back to this, right? There's a lot of options here. You can write to a stream. You can return a known output. In my case, I didn't modify the output in that example, but I could have returned null, for example. And then I'm returning a success failure code separately from the output of the function. Just remember, whatever you choose, make sure that you document in the header of your function what should be expected when an error occurs. That way, whoever's using your script will know what to look for and can ingest and interpret those errors accordingly.
Yeah, thanks, Frank. And just like we talked about error handling, right? I think it's very self-evident of why you'd want to handle errors, right? And in the same fashion, we've already talked about them. Why bother with progress and contextual awareness? It's kind of like the same idea. These are good things to do, and when you incorporate them into your basic functional programming, it makes things a lot more easy to consume and a lot more easy to operate and become, familiar with as a tool. And so for anything that's long running or perhaps operates over a large data set, it's a good idea to show progress. And so going back to that snippet we looked at earlier, where are we, how are we going to be conveying progress to this, script that's, function or whatever's calling things? One of the key elements is, and when we use write progress as standard commandlet, is we need to make sure that anything in the collection in our for each object or in our for each line there, line 1, is an array. That will enable, because in write progress, everything needs to be a number. The status needs, or the percent complete needs to eventually become a number. And that becomes a lot easier when we're using arrays, because we can take advantage of index of and count, very numerical types of quantifiers. Also, you'll notice that we are using these write progress, verbose, and warning to provide these contextual awareness to the caller or to the user. But these, whether we see these or not, are very much dependent on preference variables or whether we've assigned them with commandlet binding. Know that if you take this approach as to providing contextual awareness and you're not seeing the output that you want, there are different places to look at that we'll show you later in this talk to how you can control them. But in general, the big thing is when we write progress and it's likely going over a collection, make sure we make sure that collection is an array. And if you're not seeing the progress that you want or the output that you want, always check your preference variables, which we'll get into here shortly. And now that we kind of have understood more about some of these tools in our set, how do we wrap this all together? We have all these functions now that are doing things correctly in a way that is enabling us to provide verbose output and error handling. When we talk about making a library, we are basically having a set of functions where we can share information across them, maybe have our colleagues comment on them, have the community comment on them, help us become a better programmer. But what does a library really mean in this case when it comes to PowerShell specifically? No, it's not literally a book. We are not asking for a phone book. This is more of a colloquial term that is basically used to say a gathering of similar objects. And in this case, what that means is dot sourcing. The way that PowerShell consumes libraries or consumes these phone books is we want to do something that says, run this file in the current scope and allow all of that information to become available to me. And the reason why we call it dot sourcing, before we get into that, it's very much similar to including dependencies in C++ programming, like a header.h file, or in Python, just an include statement of an external library. PowerShell, very similar here, where you're building your own chain of dependencies. Dot sourcing, you're still probably wondering why dot. It's because the way that you invoke this method is you literally write a period. It is period, space, path to function. It's a very easy thing to trip up on from a syntax point of view because of the double dot and the very small space that could be between there. That is intentional. And to drive this point home, I'm going to let Frank walk through a couple examples of where dot sourcing can become simple and straightforward, but also where it can become very complex.
Yeah, I think the key thing to note there is that dot source files can dot source other files, which kind of builds this powerful chain of prerequisites. And just a quick example of that is this here, right? So let's pretend I'm writing a script that needs to programmatically get the Windows OS version, right? And so I'm going to dot source a get-Windows OS version.ps1 file that includes this function. Well, it turns out that that function also depends on a test for whether or not the current operating system is Windows, and testing for whether or not the current operating system is Windows needs to know the current version of PowerShell. And some of you that are pros are probably saying, well, why aren't you just using $ is Windows and PS version table? Yeah, that's true, but remember, I work on backward compatibility. I said that in my intro, and PS version table doesn't exist in PowerShell version 1, and is Windows doesn't exist prior to version 6. So I have some handy-dandy functions to help me remember that and kind of give me a consistent output. So anyway, let's show what this looks like, right? This is my function, and the purpose of this function is really just determining whether the current operating system is Windows 10 2004 or newer. And so you can read ahead and see the code to see what that looks like. But let's focus on what dot sourcing really looks like, right? So that's lines 4 and 5. I'm dot sourcing this get Windows OS version script. So period, space, period, backslash, name of the script file. The script file is in the same folder that I'm currently in, and this is a relative path, but you can also use a hard-coded path if you wanted to. And then once I've done that, I can assume the function is loaded and ready to go. And so I can then call the function, which is what you see on line 7 and 8. And just one quick tie back to something David said earlier about preference variables. In this case, in this function, you can see I'm using write verbose, right? And write verbose by default on a new shell is a silent stream. It will not output anything to the screen. But let's say I really wanted to output to the screen in this case. I can override the verbose preference variables you're seeing on line 2, saying continue. This will then send the output to the screen. But if you're going to ever modify a preference variable in your script or in your function, we highly recommend storing the original preference in a temporary variable and then restoring it at the end. So that's what you see on line 1 and 18. We store it temporarily in a variable and then we restore it on line 18. So if you make a modification, just make sure to restore it when you're done, so you don't cause downstream issues or downstream impacts to the work you're trying to do. So let's show a more complicated example. The one I showed previously was pretty linear and straightforward, but I'm going to show a more complicated script example. And what I'm going to share here is a real script that I wrote the other day, actually. This script is used to determine whether a Hyper-V virtual machine is a generation 1 or a generation 2 virtual machine. And I'm running this from the virtual machine itself. So it can't talk to the host, doesn't know anything about the host or its VM configuration. I'm running this from the VM. So this script depends on two dot source libraries. One is test to see if the system is a Hyper-V VM, and the other one is to test whether or not the system is UEFI as opposed to legacy BIOS. For those that don't know what that means. Both of these script files or functions depend on knowing whether or not the operating system is Windows. Okay, so that makes sense. I'm dot sourcing test Windows twice. That's kind of strange, but it's pretty straightforward. They both depend on that, I guess. And the test for whether or not the current system is a Hyper-V VM depends on get hardware model. Okay, so it's going to dot source that, fine. Oh, get hardware model is dependent on test Windows again, so I'm dot sourcing test Windows now 3 times. And let's add a little more noise to this diagram. Test UEFI system, get hardware model, and test Windows all depend on get PS version. So now I've got 3 things, dot sourcing, test Windows, and 3 things, dot sourcing, get PS version. That's starting to get kind of messy. And if I add the fact that test UEFI system also needs get Windows OS version, and get Windows OS version needs test Windows, now it's getting really messy. I've got 4 things calling test Windows. And by the way, this isn't even all the dependencies for this real life function. I just kind of ran out of real estate on the screen. I think you get my point. This is a spaghetti web mess of dependencies, right? And this can get pretty hairy pretty quickly as you build complexity. So what do we do about this? Well, there are some techniques to prevent double dot sourcing and even worst case loops of dot sourcing. We certainly don't want to do that. So one way you can do that is to check to see if your function is already loaded in memory. And you can see that in this code here. I'm basically getting a list of, or excuse me, I'm using the get commandlet, and I'm looking to see if my get Windows OS version command is already defined. And if it is, then great, I can continue on and I don't take any action. But if it is not defined, notice line 5, I'm saying if the resulting count is 0, then I'm going to go ahead and dot source the function from the current folder and get that loaded into memory. So that prevents me from double dot sourcing. So this is like a proactive check. On the other hand, you can also use variable flags, this is the technique I like to use the most. So in my dot sourced file, I can actually store a flag that says, yes, I was called. And also maybe that, my version number is 123. And so if you're trying to call me again and the version that is currently in memory is greater than or equal to my version, don't do it again, right? I don't want to reload myself if I'm already in memory. So just to show an example of what those flags might look like, here's a couple of them, right? And you'll see this in this following slide where I actually start assigning these. But I can put this code at the top of my function that allows me to create some variables that look strange, right? You're seeing the double underscore right between some of these words, and that's intentional because these are kind of quasi-private variables. They're not, nothing's ever really private in PowerShell, at least not to my knowledge, but this allows me to kind of name these in a way where I'm not going to have collisions with work I'm trying to do. And notice I'm storing the version number as well. And so how this might work is if you look at lines 28 to 31 here, you can see at the top of my dot sourced file, I'm going to basically check to see if the flag for the variable name is already there. So the flag that I mentioned, let me go back. That's this guy, right? We're checking to see if this variable already exists. And then next we'll check to see if the version number variable exists. And then finally, I'm going to check the version number itself and check to see if the version that's already loaded is greater than or equal to my version. If it is, then I'm not going to do anything. I'm just going to break out of this script file using the break command and not take any further action. And I won't bore you with all the other if statement branching, but basically what this is doing is it's defining those variables in memory if the function continues. So if I haven't created that flag file, or if the version number is less than the one in this file, then I'm going to go ahead and redefine the variables and then continue on, presumably, with defining that function. So a little bit more advanced here, but for those that are pretty experienced, this is a way to prevent double dot sourcing in loops so that you can ultimately build that, that function library like we talked about. So you can see how this can really be used to build that complexity. So just a recap on today's session, we're here at the end, pretty much. We've gone over some required background, so like what is a function, etc. And we've gone over a framework or a set of gut checks for you to follow for when it's a time to put your code into a function. And then finally, we've gone over and spent most of our time today on how to use functions to build a scalable, maintainable code library. And if we look at the learning objectives, I hope you'll agree that we've achieved those. So we've given you that criteria of when it's appropriate, like I mentioned. We've gone over some function scaffolds or templates. And I mentioned this earlier, but these are going to be up on my GitHub here by this afternoon. So give me until about noon Central Time or so, but we'll get those uploaded shortly. And then finally, we've gone over how to create a function library, dot source scripts, and then avoid things like double dot sourcing and some of those neat techniques. So I'm going to bring up just our contact information for a second here, just to let everybody grab this if you want to get in touch. My Twitter link and GitHub are here. And again, code is going to be posted on GitHub shortly. And David's got his LinkedIn and blog. A lot of people liked his blogs, his blog earlier, so take a look at that and have a good laugh. I love that domain name, David.
Yeah,
So I think just because the keynote went a little bit over on time, we're not going to do live Q&A, but David and I are going to jump into the Twitch chat, and we're happy to keep chatting with you all. But I just want to say thank you for letting us present. Really appreciate it.
Yeah. Thanks again. Echo my thanks here. And if you have the stamina to last later in the day, join me later for a talk as well. We'll be reviewing Azure Logic Apps functions in PowerShell and implementing a pseudo DSC with all of that. So hope to see you all there as well.